In this video, we'll control a serial in parallel out shift register with a PIC F683 microcontroller. First, we'll see the connections between the microcontroller and the shift register, and then we'll program it with the MPLAB X IDE to demonstrate 5 different examples, including shifting a series of bits, displaying a binary number, and counting from 1 to 255. We'll be using parts of the C code that we use while programming an MSP430 microcontroller in Code Composer Studio. So I strongly recommend that you check out that video as well. It also gives a detailed explanation about how the shift register works. Also, if you don't know how to make the connections between the PIC and the microcontroller, please check out my previous video, PIC and Digital I/O. Now let's see the connections between our microcontroller and the shift register. As you can see, I've already identified 3 pins on the microcontroller, GP5, GP4, and GP2. And from the shift register, we are going to be connecting the serial pin to the GP2 pin of the microcontroller. And we are going to connect the shift register clock pin to the GP4 pin on the microcontroller. And we are going to connect the register clock pin to the GP5 pin of the microcontroller. We will be connecting the VCC pin to 5 volts. We will be connecting the VDD to 5 volts. We will be connecting the ground to the common ground and VSS to common ground. And we will be connecting the 8 outputs of the shift register to the LED array over current limiting resistors. So we have 8 outputs and they will be connected to the LEDs over current limiting resistors. And we will be connecting the output enable pin to the ground. And we will be connecting the shift register clear pin to 5 volts in order to avoid clearing the shift register. Okay, now we have made our connections. We have our PIC microcontroller here and we have our shift register here. You can see that we have our serial pin connection with this yellow jumper cable. And we have the storage register clock with this green cable. And we have the shift register clock with this orange cable. So we have 3 connections from the microcontroller to the shift register. And we are connected to our PIC with our 6 jumper cables here. And we have our power supply, which is a 12 volt adapter going through a 5 volt regulator and then to the breadboard. So let's create a new project. Click on File, New Project, Standalone Project, Next. Let's choose our microcontroller. Going to choose our tool PIC3. Click on Next, again Next, and we are going to select our compiler and click on Next again. Let's name this Shift Register 1. Okay, now let's click on the source files and let's make a new main.c and let's name it new main underscore shift register 1 and let's click on finish. Okay, now we have the skeleton of our main.c. The first thing that I'm going to do is to copy the configuration bits from our previous files, and I'll go to this new main.c that we had already used in our digital I/O example, and I'm going to copy these lines and paste them here. Okay. So these will be our configuration bits. And I would like to make things a bit easier. So I'm going to try to use the code that I've written for the MSP430. So let's see if it's going to work or not. So I'm going to go to my GitHub page and we can see our C code for the MSP430. So what I'm going to do is copy as much code as I can. So I know that I won't be able to include these lines. However, I will be able to use these lines because these are the functions for the shift register clock pulse and the storage register clock pulse. So let me take and let me paste them right here. Let's go back to the code for the MSP430. I'm going to get the whole portion of the main and paste it here. What else can I get? I can get these functions and I'm going to paste them. Okay, but we need to make many modifications actually. So this line is not going to work because it's for Code Composer Studio. Right here, I'm defining the directions of the pins. So I'm going to just comment this and I'm going to write tris IO. Remember the ports that I'm going to use. Those were GP2, GP4, and GP5. So I'm going to say tris IO2 is equal to 0. And I'm going to paste 2 more lines and I'm going to say 4 and 5. So I'm setting these pins as output. So let's go through the code once again. So I'm defining an integer here and I'm using it in this loop so I can leave it as it is. So here I'm in MSP430 code, I'm setting the all output pins as 0. So I can replace it with, I can say GP2 is equal to 0, GP4 is equal to 0, and GP5 is equal to 0. Okay, let's check the while one loop. Inside the while one loop, I'm setting the P1 out register of MSP430 to serial. Actually, serial was defined as the pin of the microcontroller. So what I can do is, I can replace this one with, since I'm going to use GP2 for the serial, I'm going to say GP2 is equal to 1. So I'm setting it high. Then I'm calling the shift register clock pulse. So let's see what shift register clock pulse is doing. So shift register clock pulse is setting the shift register clock pin high and then setting it low. So let's do it PIC style. So shift register clock was connected to GP4. So what we are going to do is we are going to set GP4 is equal to 1 and then say GP4 is equal to 0. Okay. Let's do the same thing for the storage register as well. So let's comment these out. Let's copy this part and let's say GP5 because the storage register pin was connected to GP5. Okay, so let's go back to the main part. We were in the while one section, so we were calling the shift register clock pulse, and then we are setting the P1 out to 0. So what we are going to do is comment this out, and I'm going to take this and I'm going to set it to 0. And we have our for loop here. So that bit is going to be shifted through our LED array. And we've got this delay cycles function here. So remember which function we were using in PIC style, let's say. If you don't remember it, it's not a problem. So let's go to our previous example. and you can see that it's delay milliseconds. So in this code for the MSP430, I was using 1 megahertz frequency and I was delaying for 1 million cycles. So I was waiting for a second. So let's do it here. So I'm going to write 1000 here, 1000 milliseconds for a second. And it seems that it's all for the conversion. Okay, let's save this and let's try to build it to see what problems we are going to have. Okay, there are some curly brackets problems, I guess. So let's check it. I don't know, this may be the problem. Just changing the curly brackets space. Okay, the problem is I need to have the curly brackets here and I need to delete this one. So this will be for the void main. Okay, this one will be for this. And let's try to save it. I hope it's going to work this time. Yes, okay. Build is successful. Loading completed. So let's click on load. Okay, connecting to the programmer. I'm going to click OK. Okay, failed to program the device. I'm going to disconnect the PIC kit. I'm going to connect it again. Okay, let's see, it's connected. I'll click on OK. There might be a problem with the connections of this breadboard, so that's a possibility. Okay, maybe there was a problem with the other breadboard when I connected the microcontroller, so I'm going to load it on a separate breadboard. And I'm also monitoring the voltage that I have on both breadboards. I'm going to click on build once again. And I'm going to try to load it. Okay, program verify complete. So I hope it's okay. So what I'm going to do is I'm going to make the connections accordingly. So as you can see on the code, our shift register clock pulse is going to go to GP4, which is this one, and the storage register clock is going to go to GP5, and that's this one. And the serial pin is going to go to GP2, which is this one. Okay, now we can see that one bit is being shifted towards the shift register. Great, so it worked. So let's try to change the delay to observe. For example, let's make it half a second. Let's save it. Okay, build is successful. So let's try to load it again. Okay, you can see that the speed has increased. So let's increase it much more. Okay, you can see our 1 bit is being shifted in a much faster way. So it's great that we just use the code that we have written for MSP430, and with some slight modifications, we made it run on the PIC microcontroller as well on MPLAB X IDE. In the second example, I'm going to add 2 lines. Actually, I'm going to copy and paste these 2 lines in order to have 2 1 bits shifting towards the shift register. Actually, in the beginning, I had thought that this line would not be necessary. However, the output was not as I expected. So after the shift register clock pulse, I'm again setting the GP to SI and again sending the shift register clock pulse once again. So let's see how it works. Let's load it to the microcontroller. Now you can see that 2 bits being shifted towards the shift register. In this third example, we are going to be sending 101 bit series towards the shift register. So let's build it. Okay, so you can see that 101 bit series is being shifted towards the shift register. In this fourth example, we are going to be sending a series of data to the LED array. So this is going to be shown on our array like 01010001. So we are defining here a send bit function, which is going to be sending 0 or 1 bit, and we are going to see this value only. So let's build it. Let's load to the microcontroller. Okay, you can see that we see the value 01010001 on the LED array. In this last example for the shift register, we are going to be sending the values starting from 1, ending at 255 to the shift register and to the LED array. So we are going to be seeing the binary values starting from 1, ending at 255 on the LED array. So let's build the code. And load it on the microcontroller. You can see that the LED has started counting. So we have the values. This is 7. It's going to continue with 8, 9, 10, 11, etc. So actually maybe we should reduce this delay so that we see it properly. So I'm going to set it to 50 milliseconds. Let's try to build it again. Okay. Sometimes we receive such errors, so try to build it once again. So I'll load it to the microcontroller. Okay, we can see it better now. So it started counting from 1 and it's going to continue until 255. So in this video, we solved the examples for the shift register and the PIC microcontroller. And the good part is we used the code that we used for MSP 430. We copied that code and made the modifications necessary for the PIC microcontroller, like the output ports and some other small modifications as well. So we just spent just a little time to modify the code. This was the end of the video. I hope it's been useful for you. If you have any questions or comments, please write them in the comment section. Thank you for watching and see you in another video.